Let us solve this problem. In the expansion 1 plus x whole power n into 1 plus y whole power n into 1 plus z whole power n is some positive integer. The sum of the quotients of the terms of degree r we need to identify. Let us solve this problem. First of all, we can write 1 plus x whole power n into 1 plus y whole power n into 1 plus z whole power n as 1 plus x into 1 plus x into and so on up to n times 1 plus x. In the similar manner, 1 plus y whole power n, if you expand it will be 1 plus y into 1 plus y into and so on up to n times 1 plus y into 1 plus z into 1 plus z into and so on up to n times 1 plus z, which has how many factors? 3n factors. Okay, here we can observe 3n factors in this product. We want degree r term coefficient. That means degree r term, all the degree r terms we have to add and its coefficient we need to identify. Means sum of coefficients. Okay, so here first of all, number of degree r terms we need to identify. Here among these 3n brackets, we need to choose r brackets. We choose r brackets. We choose r brackets out of 3n brackets to get a term of degree r. Among these 3n brackets, if you select any r brackets, you will get a degree r term. I think it is very clear for you. If you want to identify degree 2 term, among these 3n brackets, you need to select any 2 brackets. So if I select these 2 brackets, so here variables I'll multiply. In the remaining brackets, constants I'll multiply. Like that. Then we multiply second term in each bracket. Now, number of terms each having quotient is 3n CR. Then we multiply second term in each bracket. We multiply second term in each bracket, then you will get a term with degree r. Now, number of terms each having degree r will be 3n CR. So individually quotient will be 1. So if you add all the quotients, then it will be equals to number of terms. So we can write hence sum of the coefficients will be 3n CR. I think it is very clear for you. Multinomial theorem. N is a natural number. x1 plus x2 plus x3 plus and so on plus xk whole power n. What will be the expansion? say sigma R1 plus R2 plus and so on plus Rk will be n factorial by R1 factorial R2 factorial into and so on Rk factorial into x1 power R1 into x2 power R2 into and so on xk power Rk. I think it is very clear. For example, coefficient of x power alpha, y power beta, z power gamma in the expansion x1x plus y1y plus z1 z x1 y1 z1 are any constants whole power n is natural number will be first case 0 if what is the condition alpha plus beta plus gamma not equals to n. Second condition it is n factorial by alpha factorial into beta factorial into gamma factorial into x1 power coefficient of x power alpha, y power nt, y power beta, z power gamma. We need to identify coefficients. We have to take alpha, y1 power beta, z1 power gamma. Okay. For example, if you want to identify coefficient of x square y cube z power 7 in the expansion 3x minus 4y plus 8z whole power 25. What will be the answer? Here 2 plus 3 plus 7 is not equals to 2 plus 3 plus 7 not equals to 25. Answer 0. Okay. Next example. Coefficient of x power 19, y power 2, z power 4 will be what? In the same expansion will be what? In the same expansion. So it will be 25 factorial divided by 19 factorial into 2 factorial into 4 factorial into 3 power 19 into negative 4 power 2, 8 power 4. That's it. Number of terms in the expansion of x1 plus x2 plus and so on plus xk whole power n will be what? N plus k minus 1 c k minus 1 s. For example, number of terms in the expansion of x plus 2y plus 5z whole power 20 will be 20 plus 2 c2 22 c2. Okay, that's it. Next point, binomial theorem for any index. For any index. Index means power. Okay. Binomial theorem for any index. If modulus x less than 1, then the expansion of 1 plus x whole power n, where n need not to be positive. N means the index. N need not to be positive. Need not to be positive. Okay. It will be 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube plus and so on. Goes infinitely, okay? Goes infinitely. For example, modulus x less than 1, then expand 1 plus x whole power negative 1 by 3. We need to expand this. Here n value is negative 1 by 3, so it will be what? 1 minus 1 by 3x plus 1 negative 1 by 3 into negative 1 by 3 negative 1, okay, n into n minus 1 divided by 2 factorial into x square, okay. So plus negative 1 by 3 into negative 1 by 3 negative 1 into negative 1 by 3 negative 2 divided by 3 factorial into x cube plus and so on, goes on infinitely, okay. Let us do one thing, let us simplify this. So it is 1 minus 1 by 3x plus, here you can observe 2 factorial means 1 into 2, so divided by, after taking LCM in denominator, here 3 will be there, here also 3 will be there. 3 into 6 we can write, okay. This is not 3.6, 3 into 6. So what about numerator? Negative into negative becomes positive, okay. So 1 into, here you can see 4. 1 into 4 into x square. Here you can see negative into negative into negative means negative, okay. 1 into 4 into, okay, you'll get 7 divided by 3 into 3 3 into 6 into 9, okay, x cube positive and so on. Any doubt? Now let us see the expansion of 1 plus x whole power negative 1 whenever mod x is less than 1. What will be the expansion for this? It will be 1 minus x plus x square minus x cube plus and so on plus negative 1 whole power r into x power r plus and so on, endlessly goes on. What is the expansion for binomial for any index? 1 minus nx. Okay, so here negative 1 is there, that's why 1 minus nx means minus 1x. So plus negative 1 into negative 1 negative 1. Negative 1 into negative 1 negative 1. Okay, divided by 2 factorial means both gets cancelled. Next situation, here forget about negative, so positive n into n minus 1 into n minus 2 by 3 factorial. Actually here we should get, so 3 factorial x cube, this here we have to get, okay. So n means negative 1, negative 1 into negative 2 into negative 3 divided by 3 factorial means entirely negative will come, okay. So into x cube both gets cancelled, so like this we are getting 1 minus x plus x square minus x cube plus x power 4 minus x power 5, like this. I think you got this, okay. Any doubt? Next, let us see the expansion of 1 minus x whole power negative 1. It will be 1, actually negative 1 into negative x means positive x square, positive x cube. This only we will get, plus and so on. Okay, that's it. Let us see the expansion for 1 plus x whole power negative 2. It will be 1 minus 2x plus 3x square we will get, minus 4x cube we will get, plus and so on, plus negative 1 whole power r. What will be the rth term? So here power is 2 means here we will get 3. 3 means 4. So r plus 1 whole into x power r. That's it. This is the general term, plus and so on, like this. Similarly, let us see the expansion for 1 minus x whole power negative 2. It will be in place of x, you have to substitute negative x in the above expansion. 1 plus 2x plus 3x square plus 4x cube plus and so on plus r plus 1 into x power r. That's it. In general, let us write the expansion for 1 plus x whole power negative n wherever n is some positive. Okay, it will be 1 minus nx plus n into n minus 1. Okay, n into n minus 1 divided by 2 factorial. Okay, plus negative n into negative n minus 1 divided by 2 factorial into x square plus negative n into negative n minus 1 into negative n minus 2 divided by 3 factorial into x cube plus and so on. Okay, actually this is the expansion, but after simplification it will be 1 minus nx. So here negative common, then it will be positive n into n plus 1 divided by 2 factorial into x square. So here negative into negative becomes positive, another negative. Finally it will be negative n into n plus 1 into n plus 2 divided by 3 factorial into x cube plus and so on. Like this we can write. Then what will be the expansion for 1 minus x whole power negative n? In the above expansion, in place of x negative n you need to substitute. So it will be 1 plus nx plus n into n plus 1 divided by 2 factorial into x square plus n into n plus 1 into n plus 2 divided by 3 factorial x cube plus and so on. Okay, that's it. Next problem. 1 plus k by 3 plus k into k plus 1 divided by 3 into 6 plus k into k plus 1 into k plus 2 divided by 3 into 6 into 9 plus and so on. Okay, this value we need to identify. Clearly, we know that n is negative k. Okay, so nx will be k by 3. n is negative k. Okay, n is negative k. So into x will be k by 3. So x will be negative 1 by 3. So 1 plus x whole power n expansion this is. So it will be 1 minus 1 by 3 whole power n value is negative k. That's it. Completed. Okay. Next problem. X is 1 by 3 plus 1 into 3 by 3 into 6 plus 1 into 3 into 5 by 3 into 6 into 9 plus and so on. Then x square plus 2x minus 2 value we need to identify. Let us solve this problem. First of all, let us write x as 1 plus 1 by 3 plus 1 into 3 by 3 into 6 plus 1 into 3 into 5 by 3 into 6 into 9 plus and so on minus 1. I have added 1 and I have subtracted 1. Now observe this. This is nothing but 1 minus 2 by 3 whole power negative 1 by 2. Actually, you can observe here. Okay. Now we know that this is root 3 minus 1. This is root 3. X value is root 3 minus 1. Then x plus 1 will be root 3. Squaring on both sides. X square plus 2x plus 1 will be 3. So x square plus 2x minus 2 will be 0. Answer is 0. Okay. Next problem. X is equals to 1 by 5 plus 1 into 3 divided by 5 into 10 plus 1 into 3 into 5 divided by 5 into 10 into 15 plus and so on up to infinity. Then 3x square plus 6x we need to identify. Clearly n value negative 1 by 2 and nx will be 1 by 5. Negative 1 by 2 into x, it will be 1 by 5. So that means x will be minus 2 by 5. So listen, this x and this are not equal. Okay. So let us take this as x dash. Now 1 plus x dash whole power n, it will be 1 minus 2 by 5 whole power minus 1 by 2. Actually given x here you can see 1 minus 2 by 5 whole power negative 1 by 2 lagging, 1 is lagging. This is the given x. Okay. So let us continue. X will be what? Root 5 by 3. Root 5 by 3 negative 1. So x plus 1 whole square will be 5 by 3. Okay. Now squaring on both sides I have done. So simplify this to get the value 3x square plus 6x. You try and check, you'll get its value will be 2. Once check this. Next problem. Given x equals to 1 plus 3 by 1 factorial into 1 by 6 plus 3 into 7 divided by 2 factorial into 1 by 6 whole square plus 3 into 7 into 11 divided by 3 factorial into 1 by 6 whole cube plus and so on. Then x power 4 he's asking. He's asking the value of x power 4. What is the value of x in binomial expansion for any index? clearly power will be negative 3 by 4. All are positive, then 1 minus negative 3 by 4. Yes, very good. Nx will be 3 by 6. Nx will be 3 by 6. Nx will be 3 by 6. Negative 3 by 4. X will be x equal to negative 2 by 3. Okay, negative 2 by 3. Already negative I have written. 2 by 3 it is enough. Okay, so this is the value of x. So 1 by 3 whole power minus 3 by 4. Then it will be 3 power 3 power 3 by 4. X value. X power 4 will be 3 cube. That's it. Next problem. 1 minus 1 by 8 plus 1 into 3 by 8 into 16 minus 1 into 3 into 5 divided by 8 into 16 into 24 plus and so on. Listen carefully. Here what will be the index? It will be clearly negative 1 by 2. Okay, negative 1 by 2. Next, nx will be negative 1 by 8. Negative 1 by 2 x will be negative 1 by 8. So x equals to 1 by 4. So its answer will be what? 1 plus x whole power n. So it will be 1 plus 1 by 4 whole power negative 1 by 2. See here, that's why you are getting alternate positives, negatives. Okay, if all are positives, you'll get like this. Understand? So that's it. Okay, you can simplify that.